Welcome. In this video, I'm going to show you how to demonstrate whether planes are parallel or perpendicular or neither. And if they're neither parallel nor orthogonal, I'll show you how to determine the angle between them. And we'll be giving our answers in degrees rounded to the nearest tenth. Okay, so let's take a look at both of these planes. So this first one, I'm going to just quickly rewrite. I'm going to rewrite it as negative x plus 4y minus 2z equals 0. And I'm doing that because it makes it really easy to see that the vector normal to this plane is equal to negative 1, 4, negative 2. And now I'll do the same thing for this other plane here, though this one's a little easier. So actually, let me scooch this right below. There we are. So the normal vector to this plane here, and you know what? I should distinguish these. Let me call this N1 and this one N2 and distinguish them with more than color. This is in black and this is a deep blue. So N2 is equal to 3, negative 12, 6. Okay, so now that I have these normal vectors, we have to do two things. We have to ask ourselves, are these parallel? That is, are these planes parallel? Well, what we're looking to see if the normal vectors are scalar multiples of the other. Now, to determine if these are parallel, ask yourself, is one vector a scalar multiple of the other? I should say either way works. So that is the question you're asking. Does n1 equal some scalar, I'll call it m times n2? Or you can ask yourself, is n2 equal to some other scalar? Let's call this one s times n1. Well, let's take a look at this. Can I multiply negative 1 by something to get a positive 3? Certainly, I can multiply this by a negative 3. All right, what about 4? Can I multiply 4 by something to get negative 12? I can, and again, that's negative 3. So let's see if this holds one last time. Can I multiply negative 2 by something to get positive 6? Again, I can, and that's negative 3. So we can see that n2 is equal to negative 3 times n1. So what we have just shown is that n2 is a scalar multiple of n1. These two planes are indeed parallel.